Hello everyone, Mr. Schultz here. So, welcome to a new module. This is 7-1, sample spaces. Make sure you write your information, 7-1 in the top left-hand corner, and in the top right, you put your information. Our title is sample spaces, so let's go on. When we look at probability, so let's type that in. When we look at probability, we want fair events. So for example, what does this mean? This means no weighted dice, no weighted coins. When we flip a coin, it should be a 50% chance of it being heads and a 50% chance of it being tails. Now, if it's weighted, you're probably leaning more in one direction than the other. So, example 1, define a sample space. A fair dice is tossed once. Unless stated, the die is going to be normally known as like having 6 sides. 1, 2, 3, 4, 5, 6. The sample space S includes all possible outcomes of this event. All right, well, what is this event? Well, you roll a die, you can get a 1, a 2, a 3, a 4, a 5, or a 6. Those are all the possible outcomes for rolling a die. Now, if it's more than one, it's dice. One die. Okay, what is the sample space for rolling a prime number? Now, a prime number is 2, 3, and 5. Write the outcomes to complete the sample space. All right, so let's write this down. This would be the prime number on die. And that's 2, 3, and 5. Because 1 isn't prime. Let's go on. Example 2, represent a sample space. All right, there's different ways we can represent these sample spaces. My favorite is the tree diagram, but let's show off the other ones. Jose has a red hat and a black hat. If he's going to wear one on Saturday and one on Sunday, what are all the possible outcomes? Well, he could wear the red hat on both days. He could wear the red hat on Saturday and then wear the black hat on Sunday. He could wear the black hat on Saturday and then wear the red hat, or he could wear the black hat on both days. Boom. Those are all the possible outcomes. Let's go on. It could be in a table. So if he wears it Saturday and Sunday, boom, red and red. If he wears it red on Saturday and black on Sunday, it'd be red and blacks. Now if he wears black and then red, and then black and then black. Once again, those are the 4 outcomes. Let's go on. All right, here's my probability tree. I love this one. So, possible outcome. There's 2 choices he has on Saturday. He could wear the red or he could wear the black. Sunday's choice. Now, if you're watching Marvel's What Ifs or Marvel Loki's or whatever, something happens. Divergent paths. Well, if he chose a red hat on Saturday, on Sunday he could still choose a red or a black hat. On Sunday, if he chose a black hat on a Saturday, he could still choose red and then black. Now, what are the sample spaces on here? It would be red, red, then red, blue, or red, black, and then black, red, and then black, black. Let's go on. Example 3. Finite and infinite sample spaces. So take a marble out of a bag, 3 orange marbles, 5 green marbles, 4 blue marbles. Now you're only going to take 1 marble out of the bag. That's what it says. Take a marble out. So how many? 1. So there's only a choice. The sample is going to be, let's put it right here. The sample is only going to be like orange, or it's going to be green. Oh, spell it right, Mr. Schultz. It's going to be blue. It's only one of those outcomes. This is what we call a finite example. Now, infinite discrete. Now, there's infinite discrete and infinite continuous. So, infinite discrete would be, hey, guess what? A spinner game, Twister, has 4 colors, red, blue, green, and yellow. It'll be spun until it lands yellow. Okay, well, it could be spin red, then 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 blue, then yellow. That's an example. Or you could spin it yellow, and that's the first one. Or we could spin it green, green, red, red, green, red, blue, and then yellow. There's an infinite, meaning there's so many different possible outcomes. So going back to what Loki, there's so many different Lokis. You have that alligator Loki. You have the Loki who has the hammer. You have the Loki who kills Thor. There's so many different Lokis. There's an infinite amount. So last one, infinite continuous. We're throwing and recording the height of the ball of inches. So what that means is, we could throw it up and it could be 30 inches. What if we throw it up and we make 30.5 inches? What if we throw it up and we get 30.25 inches? There's no particular discrete data. Now the other ones, there's only 4 choices, red, blue, green, yellow. For this one, it's an infinite and continuous amount between 0 and whatever the height we could go. We could do it could go up 400 inches. We don't know. But it could be any bit of information in between. All right, this should be our last one. Now here's the example 4. It's called the fundamental counting principle. So basically this is a nice way to figure out, hey, what is? Now go ahead and pause this video and shorten this up for yourself. So we have 2 things. We have a way to estimate the total number, estimate total outcomes. So for example, this tree diagram, we have 1, 2, 3, 4, and each of these has 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we can multiply 3 times how many times? 4. So 4 times 3 is 12. There's 12 different outcomes. Now let's go back and look at the other one, but go ahead and take notes on this. Pause it. Let's go on. So if we're looking at this one, how many different outcomes were there? Well, it was 2 branches, and then the second event was 2. What's 2 times 2? 4. So there's 4 possible outcomes. That's what they're asking with the fundamental counting principle. You just multiply event 1 is how many outcomes times event 2, how many. All right, guys. Good luck. I'll see you guys in class. Bye.